Good morning to all of you. Myself, Professor N.V. Hadpe from SND College of Engineering and Research Center, Evra. So now today we will discuss the topic related to numerical methods and computer programming. In that, the today's topic is solution of polynomial and transcendental equation by using bisection method. In that, derivation, numerical advantages and disadvantages. What is the basics of bisection method? Suppose there is an one equation, that is your f of x is equal to 0. F of x is your function of any equation and it is equal to 0. This is a standard equation, and by using uh, the solution of mathematical equation or any polynomial equation or any transcendental equation is, that means the equation, the value of x satisfies the equation, f of x is equal to 0. Suppose in the bisection method, suppose an equation f of x is equal to 0, f of x is equal to 0, where f of x is a real continuous function, has at least one root between xi and x2, or instead of that we can also write the x1 and x2 if f of x into f of x1 into f of xu is less than 0, means the value of x1 and x2 in that equation, in that diagram, x1 and xi and xu, in between that this is your actual root of that equation, actual root of that graph, means the in between xl and xu there is a one root is always present. One root is always present. At least one root exists between the 2 points, that is xl and xu, if the function is real, continuous and changes sign. In that, this is your second diagram. This is your sine wave. Xi and xu are the two functions. Both the values, both the f of xi and xu, both the values of xi and xu are different. If f of x does not change sign between the 2 points, root of the equation f of x is equal to 0 may still exist between the 2 points. Means in that this is your sinusoidal wave. In that the waveform is always cut the x-axis, after the some period. Means in that these are the two roots, suppose xl and xu, both the function of that, both the functions f of xi and f of xu are both the positive, means the f of xi and f of xu is greater than 0, but still there is a two roots, there is these and these two roots are present in that graph. Again, third one, if the function f of x does not change sign between the 2 points, suppose only show, we can take this graph only, there may not be any roots of the equation f of x is equal to 0 between the 2 points. Suppose these 2 points is taken, xi and xu. In between that, there is no sign change. Of a graph. That means there is no root. Which is present in between that two intervals. Like say xi and xu. F of xi is negative and f of xu is also negative. That means the f of xi into f of x2 is less than 0. This condition will not be satisfied. This condition will not be satisfied. When this condition is satisfied when any one function, the value of any one function is negative and one is positive. In that, these are the next diagram. If the function f of x changes sign between the 2 points more than one root of the equation f of x is equal to 0 may exist between the 2 points. There is a number of roots will also present. The algorithm of bisection method means how to perform bisection method for finding the root of equation. For finding the root of equation, choose xi and xu as two guesses for the root such that means the xi and xu are will be chooses or will be take in such a way that f of xi and f of x2 into f of xu is less than 0 means the function value of both the values xi and xu, the one function is positive and one another is negative. At that time, the product of that both the functions is less than 0 means f of x changes sign between xi and xu. In between that two values xi and xu, there is a sign changes. This is positive and this is negative. Again, step 2. First step is how to choose the initial guesses, two initial guesses, xi and xu. Second step, estimate the root axiom of the row equation f of x is equal to 0 as the midpoint between xi and xu as axiom is equal to how to find out the midpoint by taking a simple average. Simple average means xi plus xu divided by 2. Again, from that we can find out the axiom. Find out the axiom by taking the average of these two numbers. In that the function value of x1 axiom is negative and the function value of xu is positive. Means the next guesses are axiom and xu. Axiom and xu for finding the next value. Now check the value. Check the following conditions. F of x1 into f of axiom is less than 0. Then the root lies between xl and axiom. Then xl is equal to xl and xu is equal to axiom. Suppose second, the f of x1 into f of axiom is greater than 0, means both the values are positive. Then that means the f of the xl and xu, the xl f of xl into f of axiom is greater than 0 means the xl there is no root, there is no any root between the xl and axiom means the root which is present in axiom and xu. Again check f of x is x1 into f of axiom is equal to 0. Then the root axiom is the exact root of that equation. Suppose we can find out the next guesses xl and xu by checking this condition, first two conditions. Then again find out the next iteration axiom is equal to xl plus xu divided by 2. We can also find out the error between the two iterations. Suppose axiom new minus axiom old divided by axiom new into 100. This is an absolute relative error. for finding the next iteration, for finding the next iteration, or to find out the error, to find out the error between the two iterations, between the two iterations. Again, suppose the error is minimum, suppose error is minimum, then we can stop for calculating the next iteration. We can stop for calculating the next iteration. Suppose the error is maximum, the error is maximum, then we can go for the next iteration to minimize the error. Step 5. Compare the absolute relative error with pre-specified error tolerance. Suppose there is a one tolerance is given up to the error. This up to that value the error will be considerable. Then we can find out the approximate error. Approximate error means which is calculated by using absolute error, absolute relative error with predefined tolerance. Suppose tolerance is suppose 0.05 and the approximate error is 0.07, then we go for the next iteration. We go for the next iteration, and if the error is 0.5 and the tolerance is also 0.5, then we can stop for the calculation. Again, if the error is greater than tolerance, if the error is greater than tolerance, then we can go for the next iteration, and if the error is less than the tolerance, then we can stop the calculations. Note, one should also check whether the number of iterations is more than the maximum number of iterations allowed. Whether the number of iterations is more than the maximum number of iterations allowed. If so, one needs to terminate the algorithm and notify the user about it. Again, suppose we can take one example. We are working for down the toilet company that makes floats for ABC commands. The floating ball has a specified gravity of 0.6 and has a radius of 5.5 centimeter. You are asked to find the depth to which the ball is submerged when floating in water. The example one, the equation that gives the depth x to which the ball is submerged underwater is given by, the equation is given x cube minus 0.165 x square minus 3.993 into 10 raised to minus 4 is equal to 0. Use the bisection method for finding roots of equation to find the depth of x to which the ball is submerged underwater. Conduct 3 iterations to estimate the root of the above equation. Find the relative second. Also find out the absolute relative approximate error at the end of each iteration and the number of significant digits at least correct at the end of each iteration. At the end of each iteration means we can find out that we can solve this equation up to 3 iterations, also find out the approximate error. Suppose from the physics of the problem, the ball would be submerged between x is equal to 0 and x is equal to 2r, means 2 times resistor, means your diameter. It means that 0 is less than or equal to s is less than or equal to 2r, means r is 0.2 0.5. The radius of that ball is given. Means the two values, the two initial guesses is 0, 0 and 0.11. Means x x1 is 0 and x2 is 0.11. Then we can find out the we can solve this equation by using bisection method. Let us assume xl is equal to 0.00 and x is equal to 0.11. Then we can find out the function. First, find out the functions f of xl and f of x2. Then the f of xl is positive and f of xu is negative. Means the product of both the functions is less than 0. Means negative, it is less than 0. Means there is a one root which is present in between that two intervals. Again, this is your graph for showing the upper and lower limit. Showing the upper and lower limit. Then iteration number 1. Iteration number 1 means we can find out the middle value of xi and xu by using the equation xi plus xu divided by 2 is equal to 0 plus 0.11 divided by 2 is equal to 0.055. And then we can also find out the functions f of xm. First function of xl and xu already known. Then only find out the next function which is next value. If the newest value is xm, only find out the f of xm, means f of 0.05. This will be positive value. This will be positive value. Means we require the next value for the next iteration. We can choose the next iteration is 0.055 and 0.11 because the f of 0.11 is negative and f of 0.055 is positive. Means the one is positive value and another is negative value. So that the lower and upper limit of the new bracket are x is equal to 0.05 and xu is equal to 0.11. So we can find out the absolute approximate error by calculating the difference 0.11 minus 0.055 divided by 0.055. Next iteration number 2, xl plus xu divided by 2, 0.055 plus 0.11 divided by 2, the value is 0.0825. Also find out the f of xm. Again find out the f of xm, means f of 0.0825. This is your negative value and the positive value which is 0.055. This will be calculated in previous iteration. This is positive value and this is your negative value. Then the product of both the is negative. Therefore, the next cases are 0.055 and 0.0825. Again, find out the error 0.0825 minus 0.055 divided by 0.0825 into 100. This is your 33%. But the problem which is given that the number of significant digits at least correct at the end of each iteration. Means the correct up to the 3 to 4 digits. Again, iteration number 3, find out xm is equal to 0.055 plus 0.0825 divided by 2. The value is 0.06875. We can find out the function of f of xm. Then again, this is your negative value and positive value is f of 0.055. Then the net guesses is 0.055 and 0.06875. Again, find out the absolute relative error is 20%. This is your find up to the third iteration. Still none of the significant digits are at least correct in the estimated root of the equation, as the absolute relative error approximate error is greater than 5%. Means the error is also greater than 5%. So one more iteration should be required. So next iteration will be find out. Then up to the 10 iteration, up to the 10th iteration, the value of root is correct up to the 3 digit, up to the 3 decimal places. This is your bisection method. What is the advantages of that? Always convergent, means always go for the next step. The root bracket gets half with each iteration guaranteed. Means after each iteration, we can find out the two guesses. We can exactly find out the two guesses. Drawback is the slow convergence, means the value of the exact value, for finding the exact value, the number of iterations should be high. The number of iterations should be high. If one of the initial guesses is close to the root, the convergence is slow. Means suppose the one initial guess is exact to the near to the exact value, then the convergence is always slow. This is your bisection method. Means this method is used for finding the root of equation by using bisection method. Bisection means bisect the 2 points. Bisect the 2 points means suppose the two initial guesses are given, x1 and x2. Then we can bisect and find the next iteration. This is your bisection method for finding the root of polynomial and tangential equation. Okay, thank you very much.